Hello guys, today I will be discussing 3341 Leetcode question number 3341. Find minimum time to reach last room 1. In this question we are given a dungeon which has n cross m rooms, which means n into m rooms, which are arranged like a grid. Okay. Also for every pixel of this grid we are given a move time. We are given a value move time inside a 2D array, right? So we are given a move time where for each pixel move time represent the minimum time in seconds that you have spent in the dungeon to move to that room. For example number 1 we are given 0, 4, 4 and oh shit, and 4. Okay, so if I am here, I need to spend at least 4 seconds to be eligible to move either here or here. Okay, there is also one more catch. If I am being eligible to move, I will take 1 second to move from 0 to 4. That's the catch. Okay. So moving from here to here will take 1 second. Moving from here to here will take 1 second, given that the time spent is at least 4. Okay. Let's take one more example. 0, 2, 4, 6, 7, 3. Okay. Let's take this example. So here if I'm initially standing at 0, I will be waiting for t is equal to 2 seconds before I start moving to 2. Okay, now let's assume t equal to 2 seconds has elapsed. Now I can move from 0 to 2, but it will take 1 second. So here the time is 0. Okay, so here the time is 0. Now here the time will be 2, which is which we have to wait before moving here, plus 1 second of this movement, so it will become 3 seconds. Now for 4 we have to wait 1 second so that 3 becomes 4. Now once it has become 4, we can move to 4 by taking 1 second. So here it will account for 5 seconds, right? Okay, if I'm moving like this, now from 5 to 3, if I want to move from 5 to 3, I don't need to wait because this 5 is already more than 3. So I just need one more second to move here without any wait. So for 3 it will become 6. Now for 6 we have to wait for 6 seconds and 1 second for the movement. It will become 7. Now 7, it is all same, so I can just move immediately and take 1 second, so it has become 8 seconds. Now here 8 to 3, 1 second, so from here it will take 9 seconds. Okay, if I am going from here to here, if I'm going from here to here, it's taking me 6 seconds. But if I'm going from here to here, it's taking me 9 seconds. So what is the shortest path? This. And the time it took is 6 seconds, so we have to print this number. Okay, so you might have already figured it out. Here it looks like a graph, so we need to fetch an algorithm which is used for finding the shortest path from point A to point B, single source. Okay, so that can be Dijkstra algorithm can be used here. Okay, so for this case, time will be acting like the weight of this graph. Okay, let's first make this graph into our code in the form of an adjacency list. This is the number of rows, this is the number of columns. N. Okay, let's start making. Oh, or perhaps we don't need to make any adjacency list at all because we are already given the matrix that we can use. Okay, We just need this information. Now if I am using Dijkstra algorithm, I will be surely using priority queue. Okay, let's define one. I will explain why I'm using a vector here, okay, in a while. So initially this priority queue will be having the initial position. Okay, now here vector int becomes, will be representing time and the coordinates where the person is there. Okay, so I comma j, row comma column, in the zero indexing. Okay. Let's put the initial values where the person is. Pq dot push. Okay, we are done. Also, we need to keep track whether the person has visited any node before or not. Okay, we need to check that. So for that, we will also make one more vector, one more 2D array of Boolean values. Yep, we have made. Okay, q dot size. Now let's move through the dungeon using Dijkstra algorithm. Okay, initially we are at this place, auto current. Okay, this. Okay, so the time that has been taken is current 0. Okay, because in this vector time is at 0th index. Okay, similarly I is at 1th index and j is at 2th index. Now we have to check whether the current pixel is already visited or not. So if it is already visited, we will not continue further. But if it is, we'll just mark that node true, like that node is visited. Okay, now we have to check for all the direction. Okay, around that pixel. Like let's make some grid here. Shit, let's take the better color. Okay. Okay, this is the grid, let's say. Okay, and initially I am here. Okay, initially I am here. Now I want to go here, 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 and here, right? I can move anywhere. I have to take into account all the values. Okay, so for that I will use a vector of vectors. Zero comma 1. Yep, we are done. Okay, so minus 1 comma 0 means the current coordinates we are decreasing the row by 1. So it is, so minus 1 comma 0 means we are going from here to here. Okay, 1 comma 0 means we are going down. We are in increasing the row by 1, but not the column. Okay, similarly if I want to go to right, I'll just use this. Okay, not changing the row but increasing the column by 1. Now for the left, I am not increasing row or decreasing the row, I'm just decreasing the column by 1. So it becomes, it goes here. Okay, now for this let's move to the code. Okay, Now the new coordinates will become mm, new I n j and d1. If now what if the pixel is, what if the user is initially standing here, the he or she cannot go here or here, right? So we have to check whether these new coordinates are within the constraints or not. Then only we will continue. Okay, now one more thing you need to check. Okay, let's say for this example 0444. Okay. 0 4 4 4. Okay, here t is equal to 0. Okay, now here t is equal to 0, which is less than 4, so we will be waiting for 4 seconds and then I will be moving there, right? So if this t is less than this value, okay, I will explain. Okay, time maximum time comma maximum time comma a mm, new I new j and plus 1 for the cost of this movement. Okay, now also one very important thing we'll be discussing is soon. Okay, n comma new I comma new j, we have pushed this into the priority queue. Now one very important thing, look carefully. I will be, okay, this plus 1 first of all will be out of this max, because here max of 0 comma 4 which will be taking for us, and then plus 1 of the mode, so it will be out. The very important thing is that we will be multiplying all of this by -1. Why? Because we have to go to the minimum time, right? And this priority queue, if we have if we pick from the topmost place of the priority queue, always we will get the maximum time always, so we want the minimum time, so I am just multiplying this by -1 here. Okay, to make this priority queue as a minimum heap, to act as a minimum heap, right? So here, which means that this time will always be negative, so let's multiply this by -1 also, right? So this is the trick of making a maximum heap to minimum heap. Okay, we have done this, we have pushed. Now also we have to check whether this I and j, if I is equal to n minus 1 and j is equal to m minus 1, which means that if we have reached the end here, right, if we have reached here, so we'll just simply return the time. Okay. Yes, one more thing we have to check, whether this new pixel that we have arrived is not already visited. Okay, yep, we are now good. Also also we need to return something, so let's return -1. Let's run this code and check. Okay, 6, we have gotten 6, we have gotten 3, and here we have also gotten 3. Let's just submit this code and see what's happened. Yep, it got accepted. Okay, so let's just summarize this code once again. Okay, by with a simple diagram. Okay, let's say we have these nodes. Okay, like this. Okay, we have these nodes, and and they are connected by these lines like this. Have some patience, let me make the diagram. Yep, we are done. Okay, initially I am here. Okay, let's say the time here is whatever, because I am already present at this node. Okay, let's say the time here required is 6 seconds. Okay, I am here at t is equal to 0. So I will wait for 6 seconds and then 1 second for this movement. Okay, so I will reach here at t is equal to 7, at least 7. Cool. Same goes here, like what if I say here the time is 4 seconds. Okay, so I have to wait for 4 seconds and then I can move. So the time here will be 5 seconds. Now here let's assume that the time is 3. Okay, so the time taken here will be 6, because 5 plus 1 if I'm going through this path. Okay, okay, same goes for here. Let's say it is 3, so the time will be 7 plus 1 8. I don't have to wait because 3 is less than 7. So here time is 8, and here let's say time is like 14. Now I have to wait for 6 seconds because 8 plus 6 14, so I have to wait for 6 more seconds and then increment 1 because of this moment. So here the time will be 15, and so on. For this entire graph we will just see what's the what happens, and then in the end, if I reach this node, it is confirmed the time will be minimum because we are using a minimum heap. This is the essence of the Dijkstra algorithm. Okay, so this is the algorithm. Let's discuss time and space complexity now. Time complexity seems to be n square log n. Okay, because log n is for this priority queue. Okay, because the push and pop for the priority queue is log n, and the and we are iterating over all the pixels and in the worst case, so the time complexity will be n into m and log of n into m. So let me just write nm log nm. Share nm log nm. Yep, this is the time complexity. And the space complexity, I don't think it's much. Let's see, the space complexity is n square, right? The space complexity is n square. Maybe you want to say n square into 3 because there are 3 variables. So the space complexity is of the order of big of n square, and the time complexity is n square log n, right? So yep, this is pretty much it. I hope you like the solution. Hit like. Thank you. Bye.